Free will, evolution, and consciousness. This is an attempt to explain what free will is, how it is formed, and why it is neither predetermined nor random. Work and evolution-like processes may be very important in forming free will and perhaps even consciousness. We are engaged in work all the time, both consciously and subconsciously, consuming energy in the process. The importance of work could not be overestimated. Free will and consciousness may just be a product of our mental work while performing certain algorithms, not too dissimilar in nature from evolutionary algorithms. Animals do it too. Even plants do it. A plucked flower never regrows exactly the same, yet it also will not regrow just randomly. There is no fundamental reason why properly organized AI machines could not do the same. AI can and soon most probably will have both consciousness and free will. The necessary setup can turn out to be easier and simpler than we think. Someday computers will expand our consciousness and perhaps merge that with the consciousness of machines, but only after we develop a decent computer-to-brain interface. Until then, we can directly feel, enjoy, and attest only our own consciousness. Work. Every living thing is all the time working. It consumes energy and is working against the elements and adversaries. It constantly looks for food, looks for low-entropy energy supply, and builds its own living cells, organs, environment, and societies. The work living things perform is the opposite in results from decaying processes when they are dead. The importance of work is sometimes overlooked, especially in our thinking processes. We are interested in what we are working on. We think about what we are working on. We feel about what we are working on. Anything we are working on enters our consciousness and modifies it. Even ideas we are working on enter our conscious mind and enhance it. Perhaps ideas we are working on are all there is. They form the basis of our consciousness. And we are working on some ideas almost all the time, except when we are not, like in sleep or under sedation. But then, we are said to be either unconscious or with only some limited consciousness. Every living creature performs some work to survive. Every living creature works to resist the environment of increasing entropy and to look for food. Every living creature is conscious, to the extent of problems they are working on. Every living creature possesses free will, to the extent they have to make decisions between several alternatives. The exact mechanism will be discussed later. Complexity is a key to quality. The most intelligent part of our brain is called the neocortex. It is the outer layer of our brain, responsible for most of our high-level thinking and intelligence. All mammals have a neocortex. It is made of 6 layers, very uniform in structure, even across mammal species. All the regions of the neocortex may be primed with the same basic algorithm, at least initially. Cow's neocortex and human neocortex are very similar in structure and, most probably, in underlying basic algorithms. The major difference is simply in size. The human neocortex is larger, and that could be the main reason why we are slightly more intelligent than cows. But every living creature is conscious to the extent of their capacities. They are aware of their surroundings, and they are aware of problems they are working on. Even a living plant is aware of its surroundings and is constantly solving growth and survival problems of its own. If you do not believe me, just watch a time-lapse movie of a growing plant. Thus, let me conclude that the most important word for life, awareness, consciousness, intelligence, and free will is work. Evolution, the mechanism. Evolution is everywhere. It is in nature, in human society, in computer science. It is a powerful idea and a powerful algorithm. In nature, evolution has produced all the complex life forms we see around. Evolution has produced us. In society, evolution has produced cultures, ideas, social structures, legal frameworks, and laws. That was achieved through trial and error, through building on previous achievements, through testing of various ideas, through inheritance and mutation, as any decent evolutionary process should. In computer science, evolutionary algorithms are a very powerful computational tool, and they always work. What is evolution? For evolution to happen, we only need three basic components. First, we need some changes in existing structures, which could come either through random mutations or through recombining of existing structures in novel ways. Then we need a filter, which selects between different results of step 1, according to our preferences. The set of criteria for the filtering is called the target function. For example, in the evolution of life, the target function is simply survival. And finally, we need inheritance. The best results have to be saved and passed on to the next generations, so that they can build on previous achievements, repeating the cycle from step 1. I would argue that evolution-like processes are responsible for the development of our ideas and decisions as well. Let us consider our thinking process for a moment. Multiple ideas spring up in our minds almost all the time, including silly and dangerous ones. We evaluate those ideas and discard the bad and dangerous ones while keeping the good ones. Then we might test some ideas and remember most of the good ones. Then we mutate or recombine, mix our ideas in pursuit of even better ones. This is an evolutionary process. And yes, evolution-like processes can run within a single individual, very much like evolutionary algorithms can run within a single computer. Those are multiple ideas, which are being evolved. The existing and brand new ideas are mutated and recombined in novel ways, then run through our internal models of the world, filtered according to our needs and preferences, then implemented and remembered. This is great and necessary work we are doing, and we are doing it all the time. We are constantly evolving new ideas and new ways. This work will generally turn out to be very successful, but we will never know in advance what the results will be. And the result may each time be different even under exactly the same initial conditions. To better understand how exactly the same initial circumstances could lead to vastly different results, let us analyze evolution. Suppose you return to a certain previous step in any evolutionary process, real or simulated, and attempt to repeat the process. Even the slightest random fluctuation would lead to a different branching of the same process. The smallest random, perhaps quantum, fluctuation would ensure that the future may be different in each particular case. And fluctuations, mutations, copying errors are an essential part of any evolution. So while repeating the same evolutionary process, even under exactly the same initial conditions, you would probably get different results each time. Those results will, however, always be compatible with the real or simulated environment and with the specific evolutionary target function used in that process, in case of life, survival. The result of evolution will never be random, despite the random fluctuations within the process, and the results will always bear the signature of the world around and the evolutionary target function. In other words, if you have an ocean and the target function is survival, you can expect to evolve some kind of surviving fish. But you will never know in advance what kind of fish you will develop each time, even under exactly the same initial conditions. Random mutations will ensure that. Random mutations are quite necessary for evolution. They feed the evolution, but the outcome is far from random. Why? Because all the initially random mutations are put through the evolutionary filter, say, utility and survivability filter, or our personality filter. Thus, the final result of any evolution looks quite intelligent, is beneficial, and finely tuned for the immediate surroundings, the environment its evolutionary process was performed in. There are a few things that could be said about any evolutionary process. Evolution is incalculable, and the number of possible outcomes is uncountable. That is, you will never be able to calculate all the possible outcomes of an evolutionary process, or determine potentially the best one. Why? Because under every single branching of the evolution tree, when evolution advances into a certain direction, but not the other, it opens infinite and uncountable new opportunities under this branch, but cuts off infinite and uncountable other opportunities, which could have been available under the other branch. And this happens under every single branching event during the long process of evolution. Evolution will never repeat itself. Even if you run the limited evolutionary algorithm on your limited desktop computer, you will generally not get the same results each time. Even a single random mutation could ensure that. It can be argued that any evolutionary process possesses free will. Why? Because, generally speaking, the results are never guaranteed to be the same, even under exactly the same initial conditions. Thus, there will always be a choice, or rather multiple choices, in the process. The results will always be consistent with the environment and with the target function, so the results will never be just random. They will even look intelligent in some sense, and the results will represent the environment and the target function. We will never evolve fish if there is no water in our environment. So you have a previously not determinable result, which is, nevertheless, quite sophisticated and intelligent, and it bears the trademarks of the environment and the target function used. And there were multiple choices in the process. It is very easy to perceive the result as the free will exercised by the evolutionary process in that particular run and in that environment. Free will. Even a few years ago, any discussion about the free will used to go into one of the two major and rather primitive dead ends. If we regard the human brain as a deterministic system, subject to laws of nature, then under exactly the same initial conditions we must always take exactly the same decisions. Thus, we have no free will at all, and we cannot be responsible for our actions. Free will is just an illusion. Yes, we know there are quantum mechanics and quantum laws which introduce fundamental randomness into the process, but then the decisions we take must be just random, and that is not free will either. I hope, during the last decade or so, the science has gone past those two trivial and mistaken dead ends, but I am not quite sure. Let us take down both of them. First, even under classical physics and completely deterministic laws of nature, there is a well-known mini-body problem. That is, you can easily compute, say, planetary orbits of two planets, but the job turns increasingly complex with the addition of more and more bodies. The mini-body problem quickly degenerates into outright unsolvable if the number of components becomes really large. Thus, it will be quite impossible to calculate even a finite and deterministic universe, except if you have a computer bigger than this universe, and you perform calculations from outside. The smallest computer, capable of calculating the universe, is the universe itself. Of course, a truly limited and deterministic universe, without even a single random fluctuation, would be able to repeat itself, but such universes do not exist in nature. Yes, we can create a very limited and primitive universe in our computer that could be deterministic and capable of repeating itself, but all determinism could vanish even if we introduce a single truly random fluctuation. The real universe is not deterministic, it is quantum. It will not repeat itself twice. The butterfly effect is another way of saying it. Fundamental randomness is embedded into nature itself. You can easily make even a small desktop computer non-deterministic by simply pointing a camera to the sky and making some decisions dependent on the configuration of clouds. Or you can use a true quantum random number generator based on nuclear decay, for example. Second, saying that random fluctuations within our thought process automatically mean random thoughts, and thus no free will, is quite mistaken either. That would be equivalent to saying that random mutations and errors, say, in the gene copying process, would derail evolution and produce just random junk as a result. No. Random mutations are quite necessary for evolution, they feed the evolution, but the outcome is always far from random. Free will can be regarded as a somewhat similar process to evolution. Our ideas and thoughts can be seen as evolving within our brain. Random mutations and other modifications to already existing ideas are implemented, then tested, and only the best ideas are kept. Under a very primitive layout, the process can be seen as follows. Our brain continuously generates new ideas, including random ones. New ideas are being generated all the time, either randomly or via interaction with the external world, or by recombining already existing ideas. Some of those ideas are to be considered as mere useless fluctuations. The new ideas are being created big and small, good and silly, potentially beneficial and outright dangerous. Ideas are being created consciously and subconsciously on many levels. In our evolutionary analogy, that would be somewhat similar to random mutations of existing ideas, genes, or recombination of those ideas, genes, in novel ways. The consequences of those various ideas are then evaluated according to our personal model of the world and our values. The best ideas are then selected according to our needs and preferences. Bad ideas are discarded. In our evolutionary analogy, this would be similar to evolutionary filtering according to some target function. Based on our best ideas, decisions are taken, actions performed, and consequences observed. Best ideas are then remembered, ensuring inheritance. Our internal models and our preferences are updated. We are learning. Our moral guidelines and preferences are modified as per experience. Thus, forming and exercising our free will is constant and never-ending work, somewhat similar to an evolutionary process. All our ideas are run through our internal model of the world and our value system to estimate what will be the consequences. The ideas we select, even if initially random, bear the signature of our personalities. We are responsible for them. Even under the same initial conditions, we could easily come up with quite different decisions, but those decisions would always be filtered through our personality and our value system. Thus, they will be our deliberately worked through decisions, they will be our unforced, free decisions, and they will be our decisions. They will bear the marks of our personality. We will always be responsible for them. These processes happen in our brains on multiple levels, in parallel, consciously and subconsciously, and all the time without a stop. Like evolution, the process of exercising free will is not calculable. The set of all the possible variations is infinite and uncountable. Every decision we take eliminates multiple and uncountable branches of other decisions that could have followed the discarded ones, and opens multiple and uncountable new branches of decisions that could follow the taken ones. There is no room for any physical determinism, even under classical physics rules, as the multiple particles involved and all the interactions with the external world render all determinism impossible. But there is quantum randomness involved, of course, and we will never be able to predict what decisions the brain will take each time, even under exactly the same initial conditions. But those decisions will not be random either. They will bear the signature of our personality, knowledge, circumstances, and our thinking process, as they all have been processed through our internal filters and adjusted to our needs, circumstances, and values. All our decisions are worked through our internal world models and our preferences, including moral and ethical ones. They are our decisions. So our free will is neither predetermined nor random. It is a process of constant work by our personalities on many initial ideas, including random ones. Those initial ideas are being processed and evaluated by our brain, picking the most suitable ones, and thus we are making decisions with all the power of our brains and personalities. The decisions are not forced upon us, thus they are free, but they are heavily processed within us. And they are not random. Even if sometimes we would decide to mentally toss the coin, the reasons and consequences of such a decision are first evaluated and approved by our thinking process. All our decisions are free, but they are also very personal. Even if circumstances were exactly the same, we could still come up with a different decision each time. And each time we would not think about our decisions as foolish, at least initially. Of course, we can sometimes be forced, cheated, manipulated, misinformed, hypnotized, or simply wrong, but that does not take away our ability to exercise free will in principle, at least under better conditions. And hopefully, we will learn and be better next time. Making free decisions is, thus, hard and necessary work, performed constantly and continuously. We are alive and consuming energy while doing this important work. Our decisions are neither random nor predetermined. They represent us and the constant evolution of ourselves and our decision-making process. Our free will ends only when we die, and some will dispute even that. Every living system has free will. Free will is associated with every living and evolving system if they are sufficiently complex and equipped with proper algorithms. I would argue that even plants do exercise some degree of free will and consciousness. The plant will never regrow exactly the same after being trimmed. The plant also perceives and investigates its external environment, even if in a very simple manner. It always looks for better paths while it grows. Every evolutionary system has free will. If the computer system is complex enough and equipped with proper basic algorithms, it can possess artificial intelligence and free will exactly for the same reasons. And it will most probably be conscious while working on its problems, even if in a very simple way. How will we know? We will not know, as we are directly aware only of our own consciousness, not even of that of our child. Similarly, a sufficiently complex computer will be conscious of itself, aware of itself and the surroundings, and could tell us that in no uncertain terms, but we will never be able to attest to the consciousness of a system if we are not mentally connected to it. What complexity we are talking about? Well, there are about 25 billion neocortical neurons in the human brain. They make about 140 trillion neocortical connections, synapses, between them. That is, on average, about 5,600 connections per neuron. And each neuron, even though rather simple, is much closer to a complete microprocessor than to a mere transistor. So when we will assemble about 25 billion laptops and connect them into a network with about 5,600 average connections per unit, we will probably be able to discuss free will and consciousness with that creature. Provided, of course, proper basic algorithms are installed or evolved within, and a learning process, similar to that of human education, is properly carried through. It can be argued that large societies are also capable of learning, evolving, freely deciding certain items, and of being conscious. Of course, we will never directly feel and be able to attest to the consciousness of any other being, except ourselves. Or would we? Suppose we find some way of merging our brains and thinking processes. That is not impossible at all, at least in principle. Suppose we develop a good brain-to-brain or computer-to-brain interface. Will we be able to expand our consciousness then, and perhaps be able to merge with the consciousness of another subject, computer or human? It could be possible, and perhaps even in the not-too-distant future. We must, of course, develop some additional new technologies before that. But when it happens, some breathtaking opportunities await us there.